Today, we are looking at periodicity. So, what is periodicity? Periodicity is the recurring pattern of physical and chemical properties as we move across the periodic table. This means it is the trends of the periodic table as the atomic number of the elements increases. Today, we will be looking at three of those trends: atomic radius, ionization energy, and electronegativity. Did you know the letter J is the only letter that does not appear in the periodic table? First, we will look at atomic radius. The atomic radius of an atom is the distance from the nucleus to the outermost energy level. To measure it, you take half the distance between the nuclei of two identical atoms bonded together. Atomic radius decreases from left to right in a period and increases from top to bottom in a group. Why does this happen? As we move from left to right in a period, the atomic number increases and therefore the number of protons increases, but the number of energy levels stays the same. This means the effective nuclear charge of the atoms of the elements increases. The nucleus therefore draws in the electrons, making its radius smaller. As we move from top to bottom in a group, the number of energy levels increases. This means that the valence electrons are further from the nucleus. It also means that the electron shielding by the core electrons increases. This shielding blocks the forces of attraction on the nucleus, allowing the valence electron to move further from the nucleus, increasing the atom's atomic radius. Did you know mercury and bromine are the only two elements that are liquid at room temperature? Next is ionization energy. First ionization energy is the energy required to remove the first electron from a neutral atom in the gaseous state, while second ionization energy is the energy required to remove electrons out of a positive ion with a charge of +1 in the gaseous state. The trends of ionization energy is that it increases from left to right in a period and decreases from top to bottom in a group. This happens because from left to right in a period, the atomic number and number of protons in the atom increase, but the number of energy levels does not change. The effective nuclear charge also increases, and this causes the nucleus to draw the electrons closer, and this decreases the atomic radius. As we move from top to bottom down the groups, the energy levels and electrons of the atoms increase, which increases the strength of electron shielding. The valence electrons are now further from the nucleus, which increases the strength of shielding further. So therefore, less energy is required to remove electrons. The factors that affect ionization energy are the charge of the nucleus, the atomic radius of the atom, and the number of core electrons between the outermost energy level and the nucleus. These are the general equations for first, second, and third ionization energy. Did you know the second last element, element 117, was named Tennessine, after the US state Tennessee, in recognition of its contribution to its discovery? The final trend is electronegativity. Electronegativity is the measure of an atom's ability to form a chemical bond and the tendency to attract a bonding pair of electrons. Electronegativity increases from left to right in a period and decreases from top to bottom in a group. As we move left to right on the periodic table, the atoms decrease in size and the electrons move closer to the nucleus. The positive charge of the nucleus also becomes stronger. The result is that the outermost electrons are held tighter by the nucleus. As we move down, the valence electrons in the outer energy levels are moved further away from the nucleus. The electrons are shielded from the nucleus by the inner energy levels, which means the valence electrons can be more easily removed. Thank you for watching.